Welcome to my homework rewards. Today we're going to work on an interesting question. This is 12.329 from Calculus Early Transcendentals, 7th edition by Stewart, where we are going to work on number 29. And the question asks to find the acute angle between two different lines. So we're going to solve this problem in just 2 steps, but first let's draw it out to help us understand what the question is asking for. If we look at the first line over here, 2x minus y equals 3, we can rearrange this to give y equals 2x minus 3. And for the second line, we have 3x plus y equals 7, or y equals minus 3x plus 7. Let's draw these out. We will sketch them out. We don't have to be super accurate. The first line over here has a intercept, y-intercept of minus 3 and a slope of 2. So we can draw that by starting at minus 3 and having a positive slope. And the second line over here has a y-intercept of 7 and slope of minus 3. So it starts up here at 7, and it goes down a little more steeper. A little exaggerated, we'll try that again. Starts up here and comes down. So what we're looking for is this angle over here, which is the angle between those two lines. So you might recall that we can use the dot product formula to find the angle between two vectors. But how do we get vectors out of these lines? Well, for that, we can think of a vector that moves in the same direction of the line. So for example, like this. And you can see that that vector is going to be the same or parallel to the slope of the line. So the slope of the first line, m1, is equal to 2, and the slope of the second line is minus 3. So really, this line we can express as a vector that is the same as the slope, and for this one, we'll be going downwards. So vectors, we're in 2D space, so we need an x and a y coordinate for these vectors. To get that, you can remember that the slope of a line is equal to the rise over the run. And the slopes over here are really divided by 1. We don't write them because it's pretty obvious. So for our first vector, we have a rise of 2 and a run of 1. So what that means is that for a run of 1 and a rise of 2, we get our slope. So we can call this vector A equal to 1, 2. We move 1 in the x direction and 2 up in the y direction. And for the vector over here, we move 1 in the x and then down 3 in the y. So that means that we can say vector B is equal to 1 and minus 3. So the first step to solve this question is to find the slope of the line, of both lines, which is what we've just done. And now the second step is to use the dot product formula. So you might recall that A dot B is equal to the magnitude of A times the magnitude of B cos theta. It's also equal to ax times bx plus ay times by. So we can sort of go through here. We have all of these. These are all known. And we can find the magnitude of a and b. Just draw vector symbols on these. So that means we can solve for cos theta. So I will do some of these one by one. We can say the magnitude of A is equal to the square root of 1 squared plus 2 squared, which is the square root of 5, and the magnitude of b is 1 squared plus minus 3 in brackets squared, which equals the square root of 10. 3 squared is 9, plus 1 is 10. And we can also do ax bx plus ay by. So this is the definition of the dot product. You multiply the x coordinates and then the y coordinates. So the x coordinates of both vectors was 1, and the y coordinates were 2. That should be a plus 2 and minus 3. So that gives us 1 minus 6 is negative 5. So now we can put this all together and say that cos of theta is equal to negative 5 divided by the square root of 5 and the square root of 10. To simplify this, we have minus 5 and the square root of 50. When you have two square roots being multiplied, you can just multiply the numbers inside. And then we can also break them apart using a perfect square. So 25 and the square root of 2, which gives us minus 5 over the square root of 5 is 5, and square root of 2. And these cancel out to give us minus 1 over root 2. Now, when you do the cos inverse of this, your calculator might give you 135 degrees. Let's go back to our drawing and see what that means. 135 degrees is a big angle. It's not going to be what we were looking for, which is theta, or the acute angle. Rather, what we found was this angle over here, 135. So in order to solve for theta, we have to realize that a straight line has 180 degrees, and we know that from here to here is 135, so we just need to subtract. So we can say that theta that we were looking for is equal to 180 minus 135, which is equal to 45 degrees. So what this means is that the angle between those vectors is 45 degrees. And that's how you solve this question. So as a quick recap, the question asked us to find the acute angle between two lines. By drawing out the lines, we were able to see that this is the angle that we were looking for over here. The lines intersect each other at a certain angle. We knew that using the dot product, we were able to find the angle between two vectors, and we also learned that you can create vectors from the slope of the line. So using the slope, we were able to come up with these vectors a and b, and then using the dot product formula, we were able to solve for theta, which is the angle between those lines. So I hope this video was helpful. Please like and subscribe so you can stay up to date with all of our videos as they come out. I encourage you to try question number 30 over here, which is very similar. And you can use the same two steps that we used to solve this problem. If you're looking to practice other vector questions, you can sign up for free on MyHomeworkRewards.com. There are lessons, more videos, and we have an adaptive learning system that automatically tailors to suit your needs. Thanks for watching. Happy learning. We'll see you next time.